Right guys, we're going to do a bit of analytical geometry. So consider the following problem. It says in the diagram below, PQRS are the vertices of a quadrilateral PQRS. So S's coordinates are not provided. So let's have a look at the first question, 3.1. It says calculate the length of PQ. Leave your answer in surd form. So the answer should have a square root. It should have a surd. So to find the length of any side, the appropriate thing to do would be to use the distance formula. So I just want to highlight the distance PQ with blue. So let's use the distance formula to find that length. So we know that PQ should be equal to the square root, right, of YP minus YQ squared plus XP minus XQ squared. So all that it is now is substituting, plugging and playing. So you take the coordinates and you substitute them into the formula. The coordinate of P is 4 minus 6 to the whole squared plus 7 minus 6 to the whole squared, right? So square root of the whole thing, and we know that 4 minus 6 is negative 2 to the whole squared plus 7 minus 6 is 1 squared. So the answer is square root of 4 plus 1, which is equals to square root of 5. So that there is the distance of PQ. So this implies that distance PQ in surd form is the square root of 5. Right, there's your 2 marks. Let's go to the second question, 3.2. So if T is the mid with coordinates, is the midpoint of QS, determine the coordinates of S. So they want the coordinates of S, right? Let's first construct a line that joins the 2 points S and Q. Let's just join those 2 points. Let me use let's see, let me use green to join the 2 points, or black. Let me use black. Oh, okay, no. So there we have our diagonal, and I'm just gonna roughly show you where T is. T is the midpoint with the following coordinates. X coordinate is 7 over 2 and Y coordinate is 7 over 2. So whenever we work with midpoint coordinates, we need to use the midpoint formula. So this question requires you to know quite a bit of formulae, right? So let's use the midpoint formula. So T, midpoint T, with the X coordinate of T, Y coordinate of T should be equals to X coordinate of Q plus X coordinate of S divided by 2, and Y coordinate of Q plus Y coordinate of S divided by 2. Notice that XT is equals to that, and YT is equals to that, right? So now it's just a matter of substitution. So this implies that XT should be equals to XP plus XS over 2 divided by 2, and we have all the coordinates besides. We do have all the coordinates besides x of s, right? So this implies that 7 over 2 should be equals to 6 plus 6 plus x of s divided by 2, right? So this implies that x of s should be 1 because 6 plus 1 gives you 6 plus 1 over 2 gives you 7 over 2. So the same goes for y of t. Y cubed plus ys over 2. This implies that 7 over 2 should be equals to 6 plus yt. And yt has to be 1 because 6 plus 1 over 2 gives you 7 over 2. So ys has to be 1. So the coordinates t and k are 1 and 1 respectively. T and k are 1 and 1 respectively. And those are the coordinates of s. Right. Very, very easy. So let's go to the third question. If the coordinates of s are 1 and 1, if the coordinates of s, guys, please do consider subscribing to this channel. I do post almost on a daily basis. I have been posting every day. I also do grade 11 and 12 videos, maths and mathematics literacy. So yeah, so let us we need to prove that RP is equals to SQ. Let me just show you guys where RP is. Just draw a line there. So we need to prove that the distance RP and QS are the same distance. They are equal in length. And I think the best approach would be to use the distance formula. I think that's the most safest way to do it. The thing with the distance formula, one needs to be very cautious when applying it, because one wrong substitution can cost you all your marks. So let's find the distances, because we need to prove that the diagonals are equal in length. So let's find the distance SQ and the distance RP, and we need to prove that the diagonals are equal in length. Okay, so I'm gonna write here on the top left corner. I think we can start with PR. PR is equals to the square root of XP plus XR minus, I beg your pardon, minus XR to the whole squared plus YP minus YR to the whole squared. So it's just a matter of substituting. Substitute the coordinates in the correct places. So there we have XP. What's XP? XP is 0 minus XP. No, I think I wrote the wrong thing there. That's what I'm saying. I've already made a mistake. So it's important that you write the coordinates in their correct places. So let me correct that. The first coordinate, the coordinate of x of p, the x coordinate of p is supposed to be 7, and then that is 0. 7 minus 0 squared, and we have 4 minus 3 squared, right? 4 minus 3 squared So substitution, square root of 7 squared plus 1 squared, and we know 7 squared is 49 plus 1, and that is equals to square root of 50, and 50 is basically 2 times 25, and we know the square root of 25 is 5, so it's 5 the square root of 2. I think we also leave it in the radical form. Let's just work with surds, right? So that's the distance of PR. Now let's quickly find the distance of QS. Once again, we apply the distance formula. So QS, which is equals to the square root of xq plus minus x of s squared plus yq. That's it. It's why it's so important that you write the subscripts in the correct way. So now it's just a matter of substituting. Square root of xq in this case is, we have 6 minus 1 squared plus 6 minus 1 squared. So this is equals to square root of 5 squared plus 5 squared, which is equals to 25 plus 25, square root of 25 plus 25, plus 25, and that is square root of 50, and we see on top that the square root of 50 is 5 root 2. So therefore PR is equals to QS, which is equals to 5 square root of 2. Guys, let me just reiterate, it's so important that when you are working with the distance formula, you make sure 100% sure that you substitute the coordinates properly. So PR is equals to QS, which is equals to 5 root 2. So then let's have a look at the next question. That is 3.4, right? The question is, show that QR is perpendicular to RS. That sign there in between QR and RS stands for perpendicular, meaning the angle between those two lines should be 90 degrees, a right angle between those two lines. And by definition, if that's the case, then the gradient of QR and the product of the gradients QR and RS should be equals to -1 by definition. If those two lines are perpendicular, then the product of their gradients should be equals to -1. A very important formula that is always used in these question papers. So let me just clear the space here, right? Okay, I think it's important that we identify which lines we are working with. So when you have this type of a problem, just take note and mark we're working with QR and QP. So just use a color or something just to denote where those lines are, and the angle between the two lines should be 90 degrees. So we need to prove that the product of the gradients of those two lines, product means multiplication. for those that don't know, the product has to be -1, meaning the gradient of QP multiply the gradient of RQ should be equals to -1. So let's work out the gradient of QR. It's YQ minus YR all over XQ minus XR. This is equals to 6 minus 3 divided by 6 minus 0, which is 3 over 6, which is equals to 1 over 2, which is a half. Okay, so we have, let's work out the gradient of RS, line RS, YR minus YS, all divided by XR minus XS. So substituting, just a matter of substituting the coordinates. So let's do that. 3 minus 1 divided by 0 minus 1. This is 2 divided by -1, right, which is equals to -2. Oh, so there we have it. The product of those two gradients is -1, because -2 times half is -1. So it implies that MRS times, well, no, that's not right. It implies that QR is perpendicular to line RS because gradient QR, the gradient of line QR multiplied by the gradient of RS is equals to half times -2, which is equals to -1, right? So let's go to the next question. 3.5. It says, hence what type of special quadrilateral is PQRS? Motivate to answer. So the second part of the question is important because they're asking you to provide reasons for why you say this quadrilateral is whatever you choose it to be. Notice we have one right angle and the diagonals QS and RP are equal in length. So if you have one interior angle being 90 degrees and the diagonals are equal in length, this would mean that the quadrilateral that we are dealing with is a rectangle. So let me just write the reasons. It's a rectangle because quadrilateral R, oh no, it's supposed to be PQRS has one right interior angle, or one interior right angle, 90 degree angle. And the second reason would be the diagonals. PQRS diagonals are equal in length, so this is adequate reason why PQRS is a rectangle. No further explanation is needed. So let's look at the last question. It says calculate the size of the angle RSQ. So let's identify the angle that we need to look for. So there we have RSQ. So there's the angle that we're looking for, right? And let's write down the information that we have, that we know, that we found. It's important that you note all the information that was found on the diagram so that we can apply a certain formula to see how best we can find that angle. In this case, RSQ. So earlier on, we found QP to be root 5, square root of 5. So because this is a rectangle, it would mean that RS should also be, the distance RS should also be square root of 5, because for a rectangle, opposite sides are equal in length. So if QP is square root of 5, it would mean that RS, distance RS, line RS, the distance is also square root of 5. So there we have, and we also have the length of 5 square root of 2. And just take note, the angle R is 90 degrees because this is a rectangle. So I think we can use the cosine. We can find the cosine of S because we have the adjacent side, which is square root of 5, and we have the hypotenuse, which is 5 square root of 2. So we can find the cosine or cos S. There's the adjacent side and there's the hypotenuse. So let's use cos of RSQ. Cos of RSQ, RS, angle SQ, is equals to the adjacent side, which is square root of 5 divided by 5 square root of 2, the hypotenuse. Therefore, RSQ should be equals to cos inverse of root 5 divided by 5 root square root of 2, and this should be equals to 71,57 degrees. Thanks for watching.